Jumping into today's webinar, our today's host is going to be Mr. Vineeth. And first few minutes, I'd like to give a small introduction about him, and he can take over the session from there. So, in today's webinar, he gonna cover about the topics which are related to FE and PE, understanding the pathway basically, and next to that, he gonna let you know about the important topics that are included in water resources engineering subject. And here is the information about him or the detailed background about him. So he's a person who did his fundamentals of engineering exam during his master's third semester, in between third semester and fourth semester. And with the help of his FE exam, he got his internship while doing his master's itself. And followed by he got a job after his master's, and now he's doing as an associate engineer in a company here in Oklahoma. So working for that company, he also got chance to work for a few other companies which are centered in Australia and places like Canada. And he got good amount of experience related to the construction management projects. And not only that, he's also having great exposure related to all kinds of softwares that are useful for a quantity analysis. And here, let us hear in his own words how FE and PE changed his life, and followed by the importance of water resources engineering. I'm gonna give control to you.
Yeah, good evening, everyone. Firstly, I want to thank Manidhar for that great introduction and hope my audio is clear to everyone.
It is.
Okay, cool. So, thank you, Manidhar, for that great introduction. And I also want to thank the team for the incredible work they're doing to support students in the civil engineering and construction management community. So they are creating a real value by offering learning sessions and free webinars, introducing some essential software skills, and helping future engineers perform better in their careers. So, with that being said, let's dive into today's topic, the importance of the FE and PE exams, along with some tips, strategies, and some technical discussion on the FE topics of fluid mechanics and water resources. So the first question that comes to everyone's mind is why FE and PE actually do matter, right? So I'm not going to bore you all with every detail of what the FE exam covers. I'm sure most of you already know about it. So the FE civil or the fundamentals of engineering, it is a first step towards becoming a licensed professional engineer. So passing the FE earns you the title of EIT, which is Engineer in Training, and eventually passing the professional engineer exam earns you the PE designation. So, what can you do with the PE license? So, with that license, you can legally sign, seal, and deliver some of the great engineering designs. So, why having a PE designation is important? So, I would divide that into the four categories. So the very first important thing is you'll be having a legal authority and the responsibility. So only a PE can approve engineering drawings for the public works or the city works or the county works. Only the PE will be able to approve the engineering drawings. And only the drawings done by the PE will be approved by the county or the city owners, right? So you'll be having a legal authority. That's the first thing. And the second thing, go ahead, Manidhar. I think you raised your hand.
Oh yeah, I'm just making sure if you are sharing something.
No, I'm not.
All right, okay. In case if you wanna share something, you are welcome.
Yeah, I'll share when I go to the technical topic.
All right, okay. All right,
Yeah. So the
please
first thing
continue.
you'll be having is a legal authority, and the second thing is the credibility and the career mobility. So the employers and the clients view the PE as a mark of competence. So you'll be having good credibility amongst others, and you also will be having a competitive advantage, which meaning your resume will definitely stands out among us the other applicants. So that's the third advantage. And the fourth one is the expanded career paths. So you can be a project manager and you can be a senior engineer, and you can even start a independent consultant firm, and you can do much more with, you know, the PE license. You can be a project manager without the PE license, but you can be a project manager much more faster than other people. So that's what the other advantage is. So if you want all of these advantages, becoming a PE is essential. And that journey, and where I'm getting at this is, all of these are the advantages of PE, but we are here for FE, right? But the FE is the first baby step to get on PE. And that journey begins by clearing your FE exam at the first step. So I'll tell you my FE story, how I prepared and how it helped me get a internship while I was studying, and it also helped me get multiple offers for the full time. So let me share my personal experience. When I was in my third semester at ASU, I wasn't actively applying for jobs. So then, with just one semester left, I realized I needed to secure a full time job. I decided to prepare for the FE exam seriously, starting at the end of my third semester, probably in late November or early December. And I committed to studying 6 to 8 hours a day for an entire month, since we have holidays for the December. So I sat for 6 to 8 hours a day for the entire month. And by January, I sat for the exam and I passed it. Shortly before that, I had a casual conversation with a company vice president position guy who told me that, so he interviewed me, he talked to me what I know and what their company does. And during that conversation, he told me that FE provides a real edge in the job market. Since I only have uh, like 3 to 4 months of experience back in India working as an intern. So I don't think that would stand out in the US when I'm applying for my internships. So people might have good experience back in India that might help them. Some of the companies do consider Indian experience, but some of them don't. So they might definitely stand out. And I don't have anything to prove myself amongst other students or other applicants. So he explained me how FE provides a real edge in the job market. So I think just after 6 weeks after passing the exam, I posted it on LinkedIn. I texted him that, yeah, I cleared the exam, and then they offered me an internship right away on a call. And then after a week or something, I did all the process and then I started working with them. So from there, I didn't have to look back. For my full-time job search, I received multiple offers, and ultimately I chose to join JD Hair and Associates, or Michaels Corporation. So that's another reason. But so the key takeaway here is passing the FE opens the doors, but you still have to be proactive in applying for opportunities or doing the applications. So passing the FE doesn't mean, it comes to your doorstep. It just opens the doors and you need to go look and get it. That's the thing. It definitely provides you an advantage amongst the others. I even got a call for my full-time job. I think it's a company based in Houston. It's a geotechnical firm. They called me and they said they received some hundreds of applications every day, and the only reason why I got called back is because of my FE. Most of the people do apply for the jobs, but none of them has something to prove themselves. Even if they have 1 or 2 years of experience in India, they don't care, because as soon as you give your FE exam or pass it and put it on your resume, so it tells the company people or the fellow engineers that you're competent enough, you know the basics of civil engineering, at least in the feed systems, or you know the units, and you can understand what they are trying to train you. So that provides you an edge amongst the other students. So I get to hear that, yeah, you got this call because you cleared FE, and we think you're competent enough amongst the other applicants that we got. So that's the it definitely opens the doors once you clear the exam, but you still need to be applying jobs. Yeah, everybody needs to apply. It's the hard time of your life. You need to just apply, 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 and you might get rejects. Getting the rejections is the best part. but not hearing from the people is the worst part. So at least getting a rejection is better than, not hearing back from them. So in my opinion, the FE or the PE exams are neither too easy nor too tough, but they do require consistency and discipline to get that done. If you put in that effort, you will definitely pass. Most of you might be working, or it's hard to study when you work, but you need to give that 1 to 2 hours a day to clear this exam. FE is not that tough compared to PE, but fe FE has a good handbook, whereas the PE doesn't. PE, you need to focus on all other references more than the handbook, but for FE, it's it's solely focused on the handbook. You'll see around 70 to 80% of the questions that are based on the handbook. You'll only see at least 10% of the questions that are practical and the experience based questions. Some might be easy and some might be tough. You don't need to worry about the tougher ones, because we got 110 questions, out of which we only need around 70 to 80, I guess, to pass. And it again differs, but yeah, 70 to 80 is what needed. And you don't need to worry about the tougher ones. If it's tough for you, it's tough for everyone. And they always put some test questions. So you don't need to worry about the tougher ones. Do the easiest ones perfectly, and that's how you can clear it. And the exam day strategies. So I'll share a few strategies I used. So the first thing I learned is solving more problems. That helps me, my kind of learning. So practicing the full length tests before the actual exam would also help a lot. So I think I gave around probably 3 to 4. I bought some full length mock tests from Amazon, and some from probably I give one from the NCES uh, full length exam. And I used to track the number of mistakes that I do every time. So let's say for the first time when I gave 110 questions, I might not be able to answer 110, right? I might be only answering 90 questions. And out of those 90, I would track whatever the mistakes I made, especially the silly mistakes. We are human beings, we do make mistakes. And, and you should aim to reduce these errors going forward. That you can give an extra that will definitely give an extra 5 to 6 correct answers, which could be the difference between the passing and failing on the exam day. So, yeah, tracking the mistakes and trying not to repeat those mistakes when you're taking the next exam is the most crucial step. Also, during my preparation, I think I made a 15-page document. I'll share that with you going forward. But yeah, those are the points that are not included in the NCS handbook. Some of them are not included, but some of them are. Things I knew would help me on exam day. So I'll share that with you going forward. So before we jump into the technical topic, does anyone have questions on the FE exam or the importance of FE or any other stuff that we discussed so far?
I had a question regarding the sequence of preparation. Sometimes, when you club certain topics together, such as uh, mechanics of materials or structures, statics, these kind of subjects, that you can club them together. So something like that would also be helpful to cover the topics together at the same time.
Go ahead. Go ahead again. Sorry, I couldn't get you.
Well, I was wondering what are the topics that I could club and strategize to practice at the same time. Because it covered certain topics such as structures or mechanics of materials and statics, or you know so certain subjects such as these. Actually, you can club them together. You can prepare all of these, like 4 or 5 topics at the same time. What other subjects would be the best way to actually club them and prepare?
So the statics. So as you said, yeah, studying those are effective because you'll definitely study all together, like the statics, and then the statics helps you to solve the problems in the mechanics of materials. Likewise, today's topic with the water resources, we need to know what the fluid statics and fluid mechanics are before we go and study the water resources. So studying those topics would definitely help. So I think the civil, there is a document called CBT specs. I think, yeah, those exactly explains what are the topics that is covered and what are the topics that you need to club together. So, and you always need to look into the handbook whenever you're solving the questions. Like if you see a question from the structures, you need to go see where that is and then get back to it.
I have
So
a
doesn't matter.
question.
Yep, yep. Go ahead.
So, do you have any recommendations for like managing time and, you know, like panicking during the actual exam?
So that's a good question. But regarding the time, you need to. So the way I solved is you need to be focused on whatever the topics you know, like the geotech or water resources. These are the good topics, meaning you'll be getting a lot of, the formulae based questions. The mathematics is the easiest part, I think, for most of the people who give the FE exam, because the FE exam has a mathematics questions of 10 to 15, and those are not that tough. They're easy to focus on. So once you do the easiest ones first, I think that helps give more time on the tougher questions. So solving the easier ones first would help in the exam, as far as I know.
Okay, thank you. Like you said that you passed the FE exam. So, did you
Mhm.
find any difference in finding the jobs and, did you find any opportunities, I mean, greater compared to the previous?
Yes, I did. So my friends didn't give the exam. Like some of them did, but some of them don't. So when we compared, like we didn't have to put much efforts than the people who didn't pass the exam. Some cases they might be getting a job much sooner than we do, but in most of the cases you might be getting multiple offers. I know the job market is a little tougher right now, but still you'll be seeing good amount of callbacks from the people if you have an EIT certification. Put it on your resume, so that way, yeah, definitely it provides you an edge. Or yeah, I've seen a number of calls coming up for my full-time jobs. I think I got maybe 4 or 5 offers from multiple companies. So that itself tells you you'll definitely be getting a better advantage than the other people. And also another strategy, whenever you see questions on the exam, like some questions might be annoying, like they might be too large, or it might take out of your interest. But search for those keywords and try to, if you have time, solving the easier ones first, and then if you go to the harder ones, try something from the question to type it in the handbook and look at the control F function and see where that is. That helps. That definitely, it might be an easier question once you know the formulae, or once you know the stuff that's in the handbook, you can solve it. So it's about knowing where that is and looking for it with patience is the key for this exam. Even that's for FE or PE. For PE, you need to look into the multiple references and also the handbook. Does anybody have any other questions regarding FE or PE or the
Hey,
jobs?
hey,
Yep,
Vineeth. Yeah,
go ahead.
yeah. Is it okay if I skip completely one of the topic to pass FE, or is it mandatory they have to check every subject minimum percentage
Uh, to secure or to study? What are you talking about? Like giving the
to
exam?
secure, like to pass FE? You know?
I don't think you need to get a minimum marks in every topic. I'm not sure.
Hmm.
Again, NCS doesn't specify anything like that, but
Yeah,
it's
yeah.
all.
I see that they don't say anything about it, but I
Yeah,
don't know
there is.
anyone who have a diagnosis got already. So I'm just asking this question.
Yeah,
Yeah,
maybe the people who have failed would know,
yeah.
would give the diagnostic report and they would know it. But I don't think, yeah, I think they do calculate overall, because even if you have less marks on one of the
Mm.
topics, I think you can still pass the exam. So the biggest thing is
Okay.
you won't be getting any diagnostic report once you pass the exam. So you won't be
Yeah.
knowing we got mathematics 0 and still I passed or no. So yeah, it's tough, but yeah, it's always good to focus on all topics. But
Yeah.
you'll definitely see some easy questions on each and every topic. All you need to do
Oh,
is look for the keywords in the handbook. Definitely you'll see some easier questions in each and every topic.
okay. And you wrote your FE from Texas State, right? Sorry,
No, I have
the
given.
P. Sorry.
No, the PE is from Oklahoma, since I work in
Oklahoma.
Oklahoma. And you can
Okay,
give
okay.
the exam from any state. That doesn't stop you from
Yeah,
giving.
I'm currently based from Virginia, so I have to
Hmm.
check with the PE requirements. Yep. Thank you.
Does anybody have anything? All right. I think we can jump into our technical talk. Go ahead. Somebody else.
Yeah, so actually, I did masters in IT field, so and
Okay.
also I'm planning to take over the exam of FE. So, which state would you suggest me to take the exam?
Did you do the masters in other discipline,
Other,
not the
yeah,
construction
other discipline,
management?
not the construction management. Yeah,
You did the construction management or not?
no. I did masters
Okay.
in project management related, so I'm planning
Okay. You're
to
giving
take,
the FE exam in civil or the
yeah,
general FE? Okay.
the general, yeah, the civil engineering. Yeah.
Okay, so you might have some other reasoning behind it, but yeah, I think Michigan do have some easy process to do while you're doing an application for the FE exam. I don't know if there are some other states that are easy to apply, but I I think Texas is a bit difficult. I don't know what are the instructions that needs to be done by us, but
Mm-hmm.
I think Michigan is pretty easy to apply. I think yeah, I got very less time to do, so I went with Michigan since they are the ones who accept all the stuff so easily and without submitting any transcripts back in the country where you did your bachelor's or something. So I think I chose Michigan for that reason because it's easy to process. And for my EIT certification, I used uh, I applied through Maryland because they are the easy ones to give you the EIT certification. So I would have applied to Texas or Oklahoma, but Texas asked me for the transcripts from India for the EIT certification. So Manidhar, I
Okay.
think you
One
have a
more
question.
question.
Yeah,
Yep.
I would like
So,
to add few other points to your words. Here is the thing, Bhaskar. So as you said, you did your masters from IT. Not only you, this is the same scenario which is happening with many other candidates. So very few of the states stop you to take your test without having your master's here. So it should not be any obligation. And many of the candidates who take FE, they do not have any master's degree. So keeping that situations into consideration, what I can say you is that like excluding few states, states like New York, they don't allow you, and there are quite few other states which do not allow you to take the test without having a ABET certified degree. So be it bachelor's
Okay.
or be it master's, they do not allow you. But maximum of the states, when I say maximum, going to be like a count of 43 to 44 states, they're gonna allow you to sit for FE exam, though you do not have your master's related to civil engineering. That should not be a biggie,
Okay.
but there is a lot other things which we got to worry, like the concept of OPT, right? We got to do the job related to master's background that we do. That's one other aspect which we have to deal. Of course, that's a after scenario, but for exam, yeah, definitely many of the states allow you to sit for the exam, and hope this
Okay.
is helpful for you. Over to
Yeah,
you again.
yes, I understand.
I think even I heard from
Thank you very
people that
much.
without any experience or without any degree, even the some of the state boards would allow you to give FE and PE exams with some sort of restrictions that your work should be related to civil engineering or stuff like that. But yeah, you need to reach out to the boards and see what they need and what you have, and then yeah, you need to figure out what that's need, what is the state that you can give. So
Okay, thank you.
so I was asking for the resources. What of the resources you have followed before taking the exam? Since in the class, we will be solving real less problems. So I just wanted to know what is the most effective way for finding the resources while preparing for the exam.
So while I was preparing for the exam, I didn't take any other course. The reason why I didn't have a good amount of time to prepare, going through all the lectures, and that's another reason. But yeah, having some sort of resource like like these people provide you the lectures, right? This helps you understand because they are the ones who know the topics which are important or not. But in my case, I don't know what the important topics are. So I followed a strategy. I looked into online sources. I got a Drive link through Google, which has lots of questions on every topic. I don't know where I got that, but yeah, that's a good resource. But the solutions are somehow messed up for some of the problems. Those are not correct. So I used that. And also, I looked into YouTube videos. I think there's some YouTube lectures that helps you understand the types of questions that will be asked in FE. And I also did some of the problems from Leidenberg book. Very few questions because I don't have time to solve all of the questions. So, and I did good amount of mock tests or the full length test before my exam. I think that helped me a lot because I've seen the first exam I took. I got only 70 questions correct out of 110, and the next time I gave it, and I tried to lessen my silly mistakes that I did on the first exam, I could cover 5 to 6 questions in the next exam. So I would have get 76 or 80. So I got good amount of exposure to the full length exams. I think that helped me a lot, and I suggest you to do that as well.
Okay. So this might be a lame question. I don't know
Yep.
when, I mean, when I'm following the lectures and all, I'm kind of lost and I just don't want to, do it again. So I
Mhm.
don't know, how can I motivate myself while preparing for this? I'm just lost watching the lectures and all. And then later on, I just skipped all the lectures and then I really don't know what's going on after that.
So I would say that yeah, everybody, it happens to most of us, but so giving the full length test, or try quizzing yourself on a topic or on a full length test and see where you stand out, and that's when, and calculate yourself and see what are the mistakes you did. And if you might remember that something that happened in the lecture you see in the exam, and then I think that motivates you to go back and see what happened in the actual lecture. And I think that helps, and that motivates you to answer the question in the next exam. I think that's the only way, and you need to push yourself up. And yeah, it's tough sometimes, but you need to do it for your future. So
Yeah, for sure, man. Thank you much, man. Appreciate it.
yeah, no problem. Anybody have anything else? Let's get into the technical topic here.
Oh, yeah, man, for sure.
Let me share my screen. Can you all see my screen?
Yeah,
Yep,
we
you
can.
can.
Okay, cool. So the two subjects are connected, the fluid mechanics and the water resources. So the fluid mechanics is a base or the foundation for the water resources. So that's the reason why we are covering both the fluid mechanics and water resources. I don't know I'll be able to cover the hydrology part or not, but yeah, based on the time constraint, we'll briefly discuss about these two topics in this session. So in the FE civil exam, I think you'll be seeing somewhere around 10 to 15 questions out of 110 come from these areas, the fluid mechanics or the water resources or hydrology. That's about maybe 13 to 14% of the exam. So, but the good news here is many of these questions are plug-in type questions where you can just look at the question and find where that is in the handbook. And once you put in the values that is given in the question into the format that you see in the handbook, I think yeah, you can get the answers. Most of these questions from the water resources are plug-in check type, but the only thing or the caution that you need to keep in your mind is even with the straightforward questions, mistakes do happen. I think I caught myself sometimes even misreading the value or typing a wrong thing into the calculator. I would I would write something on the paper that is not even given in the question. Let's say if the question says 5 meters per second or 5 feet per second, I would have written 15. I don't know why, but yeah, fixing those errors would help you get good amount of uh, plus points on these topics. So you always need to keep in mind whatever you're writing on your paper or whatever you're seeing on the questions tab is important, and you need to put your 100%, and your brain should be attentive on what you're seeing and what you're typing in. So it's easy to misread a value or type something wrong. So that's something. Go ahead. Okay. We'll start with the fluid mechanics, which, if I remember, is covered around page number 176 of the NCES reference handbook that you all might have. And then we'll move into the water resources. So the topics that we're gonna cover today is fluid properties and the fluid statics, the fluid measurement, the fluid flow measurement, energy and momentum principles, the basic hydraulics, the Manning's equation, the open channel flow energy equation, the Bernoulli's theorem, and the water distribution systems and the flood control systems, stormwater control and the collection systems, and also the groundwater, uh, where you see the wells, aquifers, and the drawdowns. So the key definitions and the formulae that's in the very first part of your handbook are these. These are, I don't think you'll be seeing a direct question on these formulas, but these are something that might be helpful to solve some other questions. So let's say if you have a question, uh, something, I'm not used to all of these scribble pads before, so just bear with me. But if you see a question based on energy equation, you might need to know what the specific weight is, because the energy equation goes something like this. If the specific gravity or the specific weight is not given and something like the density of the material is given, that's when you need to know what the specific gravity is. And once you know what where to use this, these are essential. These formulas are the basics, or these are important in solving some of the other questions that you see on the exam. So you don't need to remember any of this stuff. These are already in your handbook. So you have some density formulas, some specific weight. It says density into the acceleration due to gravity here. I don't think you have specific volume equation in the handbook, but this is something that you need to remember for your exam, because I think the civil CBT specs for FE civil exam says covering the specific volume topic is also important. It's nothing but the reciprocal of the density, which you just need to keep in mind before going to the exam. You might see something. So you have the standard water properties. If you try to remember this, these are well and good, because you see lots of questions going around, and you need to know what the specific gravity of water is, or what's the specific weight of water is, and what's the density of water. So the density of water is 1,000 kilograms per meter cube, or in the metric system, and in the USCS units, it's 62.4. This value right here, you need to remember this uh, as much as you can. The specific weight of water is 9,810 Newton per meter cube, or 9.8 kilonewton per meter cube. And then you have the stress formulae, which everybody knows, force over area. And the only difference between the pressure and the stress is both have force per area, but stress is internal, whereas the pressure is external. And then you have the normal tangential stress and the normal stress and tangential stress. We'll see what mu is going forward. But yeah, going to the next slide, we have the pressures to discuss here. The fluid pressure is always measured with two things. One is through the gauge reading, and another one is through the vacuum reading. So the gauge reading always takes or considers the P atmospheric as absolute, or as a zero, or as a datum. So we can understand this way the pressure on the y-axis here. And let's consider this to be P atmospheric. And then this is your P gauge reading. And then this to be your P vacuum reading. So the P atmospheric is something that is standard, which you need to remember is 101.3 kilopascals. This is something you need to remember. Sometimes they might give you in the question, but most of the times they don't, and you need to know what P atmospheric is. So as I told you, the pressure is always calculated in the fluid with gauge reading or with the vacuum reading. So whenever you have a gauge reading in the question, it always says, or it is considered to be taking as the P atmospheric pressure plus whatever the gauge reading is. So the absolute pressure in this case is the P atmospheric plus the whatever the gauge reading is. That's the absolute pressure when you have the gauge reading in consideration. On the other hand, when you have the vacuum reading, the absolute pressure in that case is the P atmosphere minus vacuum gauge. I think you have this in the handbook, but yeah, to be clear, the absolute pressure in the second case is the P atmospheric minus whatever the vacuum reading is. So this gives you the absolute pressure in the second scenario. So remember this as a vacuum. I think you have this in the handbook. You don't need to remember this, but yeah, it helps whenever you have. But you need to remember what the atmospheric pressure value is. It's 101.3 kilopascals. And moving to the viscosity. So the dynamic viscosity, it's a measure of the fluid's resistance to flow when acted upon an external force. Whenever an external force is applied on a fluid, the resistance to its flow is called as the dynamic viscosity. Then we also have the formula for kinematic viscosity. It's nu is equals to mu over the density. And then we have the surface tension and capillarity. I Yeah, you have all of these formulas in the handbook. You don't need to remember any of this stuff, but you just need to know where these are located in your handbook. So coming to the surface tension and capillarity. So the force over the length is considered as the surface tension before we dive into the topic capillarity. Let me clear this up. So let's consider a beaker full of water, or not full, but with water, and then a beaker filled with mercury. So, and then you have a thin wall mounted tube in both the beakers. And then once once you have this, the water inside of the tube here will be forming something like this shape, and then in the mercury it forms something like this. So the reason behind this is the adhesive forces in the water is more than the cohesive forces, and then the cohesive forces in this scenario is greater than the adhesive forces. So the adhesive forces is nothing but the forces, the intermolecular forces between two different type of particles. Like in this case, the force between the water molecules and the glass tube molecules is greater than the cohesive forces. So that's the reason why you have the convex shaped form on the water scenario, but then you have the concave type of formation on the mercury. And for the capillarity form, the capillary rise in this case is, so let's say this is a shape that is formed, and then if you extend this, this is the beta that's shown here in the formula. So you have this formula and you just need to plug in the values and you'll be getting the capillary rise. What's the capillary rises? So the sigma here is the surface tension. As I told you, it's just force over the unit length, the length, and beta is the angle that is formed right here in the glass tube and the shape that is formed. And gamma is a specific weight of whatever the liquid that is considered, and then d is a diameter of this particular thing. And if we go and see the next question here, a vessel is initially connected to a reservoir open to the atmosphere. The connecting valve is then closed and a vacuum of 65.5 kilopascals. So you have the vacuum reading here, which is 65.5 kilopascals. Assuming the standard atmospheric pressure, meaning it is not given here. The atmospheric pressure is 101.3, which you need to remember is this much. And then what is most nearly the absolute pressure in this vessel? As I told you, the absolute pressure is calculated in both the ways. The absolute pressure, one with the gauge reading and one with the vacuum reading, and it is always added to the P atmospheric. So since the vacuum reading is given in this question, we need to go with this formula. So the absolute pressure is the P atmospheric pressure, which is 101.3 minus the vacuum is 65.5, which gives somewhere around 30s. So the option that is closest here is 36 kilopascals. So this is an easy type question which you might see. I think I have seen this question on my exam when I give it. This is a simple one, just need to plug in the values. But the only thing here is you need to know what the atmospheric pressure standard is. I don't know if this is in the handbook, but I don't think you have it in the water resources section. If it is, then it's well and good. But otherwise, you need to remember. And then going to the manometers. So the manometers are nothing but these are the something that can be used to measure small pressure differences. And for this purpose, they provide good accuracy in calculating the pressure differences. A difference in the manometer fluid, it indicates the pressure difference as in height. So the difference in the pressure between the two different points here, P2 and P1, is given by this formula, the gamma into the Z2, the height of the pressure point, 2 minus the height of the pressure point at P1. So the reason for the negative sign here, the pressure decreases when moving upwards in a fluid. Let's say when a fluid is moving upwards, the pressure decreases when you're going up. Therefore, the pressure at the point right here, the P2 is will be less than the pressure at the lower point P1. That's the reason why you are having a negative sign here. And then for a simple manometer, I think you'll be seeing maybe one question, one or probably one from the manometers. So it's good to know how to write the equation for the manometers when you're calculating the pressures. So once if you go to the manometer equation here, so always try to you're trying to find the pressure at different points here. So the pressure at P naught is always equals to the pressure at the other end, P2, plus if you're going down, then the pressure at this segment right here is, let's say, I'll divide this into a horizontal line. And this is the specific weight of this liquid right here is gamma 2. And if you're going down, you need to take it as positive and gamma 2 into H2. And if you're going beneath this, you can even ignore this because it get canceled out. But if you want to write it, you can write something as gamma 2 into, let's consider this height to be x. So this will be gamma 2 into x. And then you're not worried about any of the horizontal segments here. You're only worried about the vertical segments and the vertical heights. So you can ignore about this horizontal segment right here. And then here we're going up to reach point P naught. So it needs to be negative of, since the liquid is same in all of these sections, I'm gonna do gamma 2 into the height is also the same, so gamma x. So we can cancel these two out. So that's the reason why I told you you don't need to consider anything that is below the line here. And once you're going up, you have another liquid which says fluid 1 or gamma 1 is the specific weight of that particular fluid. So that's plus, if you're going up, it's negative. So gamma 1 into H1, and then you're not considered about the horizontal segment here. So that's how you write the equation for the manometer. I think you have a problem here going into the next slide here that will clear your mind better. And this is important, and you need to know how to write the equation for the manometers. I think you'll see a question definitely on this one. Most of the times in every mock test or the full length test I've given, I've seen a question from the manometer, like writing the equation or calculating the height or calculating the pressure at different points. So it's an important topic. And then we have something called a barometer, which is also a simple device that works on the same principle as the manometers, but it just calculates the P atmospheric or the P vapor pressure is equals to, sorry, the P atmospheric pressure is equals to the vapor pressure. And if you're going down, it is gamma into H. So it calculates P atmosphere is equals to the vapor pressure on top of this point plus going down, so gamma into H. So this is how you calculate the atmospheric pressure in a barometer. Then going to the question here, the one leg of a mercury U-tube manometer is connected to a pipe containing water under a gauge pressure of 100 kilopascals. the mercury in this leg stands 0.75 meters below the water. The height h1 is given. The mercury in the other leg is open to the air. The density of the water is 1000 kilograms per meter cube, and the specific gravity of the mercury is 13.6. The height of the mercury in the open leg is most nearly. So it's asking us to calculate the height of the mercury in the other leg. So you need to write the manometer equation before you solve for the height for this question. So as I told you, the pressure at this point, let's consider it to be P naught, since we have done the same way in our problem before. So it's P naught is equals to the pressure at the other end, which is P2, if you're going down, plus gamma of the mercury into the height h2. You're not concerned about anything that's below this line since it gets canceled out. So, and again, it's going up, which is gamma water, sorry, it's negative, gamma water into the height h1. That's how we write the equation for this simple manometer. And then you have the P naught to be 100 kilopascals, which is 100 into 1000 pascals, is equals to the pressure at this point is considered to be zero since it's atmospheric pressure. And since we have the gauge reading, the gauge reading always considers the atmospheric pressure as zero, or it considers it whatever. So let's consider something as a tire. And whenever you put a gauge reading, which is all these labels, which says 10 psi or 20 or 30 or 40, it gives, whenever the nozzle is connected to the tire here, let's say it says 40 psi. This means it is not calculating whatever the atmospheric pressure is. It's taking into account that the atmospheric pressure is zero plus whatever the pressure in this tire is, it's showing this. So it's considering, whenever you're putting a vacuum gauge, it's considering the atmospheric pressure to be zero. So since we have a gauge reading, the P2, which is exposed to the atmosphere here, is considered to be zero. So the zero plus the gamma in Hg is, so the mercury, the density of the water is given here. So the gamma is, so if you go up, as I told you, the formula, the basic formulas that will be helpful somewhere else. So the gamma is equals to the rho into g, or the specific gravity is rho upon the rho of the density. So here, in the question, since the specific gravity is given, the specific gravity is equals to the density of whatever the substance is, which is mercury in this case, over the density of the standard, which is the density of water. So the specific gravity is 13.6 of mercury, and we need to find the density over the water. Water is again 62.4 or 1000 here in this case, which is in metric. So once you calculate this, you'll be getting the rho hg. And then once you put rho is equals to gamma into h, you'll be doing something like this, and then you'll be having the gamma of hg. I'm not solving all these questions since it takes a lot of time for now, but going forward we'll do all of questions in detail. And the water, gamma h2 of water, and the height here is 0.75, and that's how you calculate, you'll be getting the height h2 in this case. So going into the next one, which is Archimedes principle and the buoyancy calculation. So the Archimedes principle tells, let's think of something like a beaker again, or a mass that's connected to the weighing scale, which is 200 grams. Let's consider this to be 200 grams. Whenever the water is filled into this beaker, and then you have a small protrusion or a hole at the bottom, and the water goes into a small beaker right here. So whenever you put some weight into this one right here, sorry, you won't be having any protrusion, you would be having the protrusion right here. So whenever you put some weight in, the water gets displaced, and this water flows into a small beaker right here. And if you measure the weight of this water collected into the small beaker right here, let's say if this is 200 grams or 300 grams, this, meaning the buoyant force that's exerted on this block right here by the water is equals to the pounds force of the mass that is collected. So which is 300 pounds force in this case. So the weight of the water displaced, or the weight of the fluid that is displaced by the body, is equal to the buoyant force exerted by the body. So the floating body displaces the weight of the fluid that it's equals to the own weight. So as I told you, the 300 grams is equals to the buoyant force of 300 pounds force. So that's the buoyant force that's exerted by the water onto this block. That is equals to the weight displaced. The center of the buoyancy is located at the centroid of the displaced fluid volume. That's just a statement which might be helpful in answering the theory type questions. Then going to the continuity equation, which is important. I think you'll be seeing good amount of questions, or at least the application of this continuity equation in different questions for your FE and PE stuff. So it says the flow or the discharge is equals to the area into the velocity, and this is constant if you have, let's say you have a pipe that's something like this, and you have the area A1 here and then the velocity here V2. You have some velocity V1 and V2. So in this case, you'll always need to do A1 V1 is equals to A2 V2, which is the principle of the continuity equation. Or if you go with the mass flow rate, then it's rho 1 A1 V1 is equals to rho 2 A2 V2. If you put this equation into consideration whenever you have the applications of the continuity equation, you'll be able to solve what is needed if some other variables are given. I think we have a question going forward that will help you clear your mind. And next we have the energy equation, P1 over gamma plus Z1 plus V squared over 2G, that is equals to the pressure at a point. So let's consider the pressure right here is P1, and then right here is P2. And then you have heights H1 and H2 from the datum line here. So the equation goes P1 over gamma plus Z1 is the height of the point pressure P1, and then V1 squared is a velocity over 2G is equals to the P2 over gamma plus Z2 plus V2 squared over 2G plus HF is a head loss. So the equation can also be rewritten as rho G plus Z1 plus V1 squared by 2G plus rho 2 by rho G plus Z2 plus V2 squared over 2G plus HF. And this is the energy equation. And you'll see a question on this probably, or at least the application of this. And we have the Bernoulli's equation. So the only difference between the Bernoulli's equation and the energy equation is the head loss term. The head loss is taken into account in the energy equation, but it doesn't in the Bernoulli's equation. So in the energy equation, the P over gamma is called as the pressure head, which is a theory question again. The V squared by 2G is called as velocity head. Sometimes in the question, they just mention you the velocity head of this flow is maybe 12 point something. That means the V squared by 2G is 12 point something. You need to put this into the equation. That's how you solve the questions based on this. And the hydraulic gradient line and the energy gradient line. What is the energy gradient line? The P over gamma plus Z1 plus V squared over 2G is called as the energy gradient line. And as I told you, the P over gamma is pressure head, V squared over 2G is the kinetic head, and the hydraulic gradient line is P over gamma plus Z. So this might be another theory question. I think I've seen one of the question in the mock test where it asks about what is a hydraulic gradient line is, and it is the term P over gamma plus the height Z. So with this, we can write the energy gradient line is equals to the hydraulic gradient line, which is P over gamma plus Z plus whatever this is missing, the V square over 2G. So with this, I can tell the energy gradient line is equals to the hydraulic gradient line, which is P over gamma plus Z plus the velocity head. So this is something that you can come from all of these principles right here. So coming to the Reynolds number. So the Reynolds number, it is a quantity or the number that predicts whether the flow is laminar, transitional, or the turbulent. So Reynolds, scientist Reynolds studied the fluid mechanics and he derived this formula for the Reynolds number. So the laminar flow, it's smooth. If the Reynolds number is less than 2000, then it is called laminar flow. I think this is in the handbook. And if the Reynolds number is greater than 4000, then it is turbulent flow. And what if the Reynolds number is in between 2000 to 4000? This is called the transitional flow, where it changes from the laminar flow to turbulent once it reaches out the 4000 or the minima or the maxima of this Reynolds number right here. So the smooth or the laminar flow is always smooth and it's steady and systematic. On the other hand, the turbulent flow is created because of the obstruction of a laminar flow or maybe due to some other force that's causing it to be turbulent. But it's not smooth and it's chaotic and it's not steady. So the turbulent flow, imagine you're turning on a tap water and it's flowing steadily without any disturbance. That's considered to be a laminar flow. And once you obstruct the flow of the tap water with your finger or hand, then it's changing something from laminar flow to a turbulent flow. So that's the basic difference between the Reynolds number. Again, the Reynolds number is calculated with rho v d by mu, where v is a velocity and d is a diameter, and rho is a density here, and mu is a kinematic or dynamic viscosity. So we have a question: an uncompressible fluid flows through a pipe with an inner diameter of 10 centimeters. Say we have a diameter of 10 centimeters, and then the velocity is 4 meters per second. Then the pipe contracts to inner diameter of, let's say this is d1 and v1, and d2 is 8 centimeters. What is most nearly the velocity of the narrower pipe? Let's imagine something like this, and then it's decreasing the diameter since it says contract, so I'm reducing. Let's consider the diameter here is 10 centimeters, and then the velocity at this point is 4 meters per second. And then the diameter at this point is given as 8 centimeters. We need to find the velocity at this point. All of these units are in meters per second. But you need to remember that the diameter here has the units of centimeter, which you need to convert into meters before inputting into the continuity equation.
Meter.
So, yep, go ahead.
We need to put diameter in the meter so that we can find.
Yep, yep, that's correct. So the A1 V1 equals to A2 V2. Since the diameter is given in centimeters, we need to convert this to meters. You're correct. So the area formula is pi d square over 4 into V1 for a circular section. So pi d2 square over 4 into V2. Since these are same on the other side, so it gets canceled out. So the d1 is 10 centimeters over 100 square into V1 is 4 meters per second. This unit is in meters. So is equals to the D2 is 8 over 10, or sorry, for 100 square into the velocity, which we need to find. Once you, I think you have everything except V2. Somebody has anything, or it's mistakenly unmuted? I take the silence as none. So the V2, if you calculate V2 here, in this case, you'll be getting somewhere around 6.3 meters per second. The only thing in this question is the unit conversion. You need to be sure in converting the diameter from the centimeters to meters whenever you're putting in this formula, since we have the velocity in meters and all of the answers is in meters. So you need to convert from centimeters to meters. So that's the reason why I always say the unit conversion is important for hydraulics or in the transportation questions. The next topic here is the friction losses in the pipes. So the friction losses, the losses in the pipes is calculated using two equations, which are stated in your handbook. So it tells the friction losses
आगे
in
बैठना
pipes calculated
आगे बैठना है
using Darcy
मिसबाह
Weisbach
लगेगा
equation
अंजुम को भी है
or
मीटिंग
the Darcy Weisbach equation or the Hazen-Williams equation. So whenever you see the friction factor in the question, you need to think about the Darcy-Weisbach equation. Or whenever you see the Hazen-Williams coefficient, you need to know that you need to use the Hazen-Williams equation in calculating the friction loss. So these are the key things that you need to remember for your exam. Let's say for the Manning's equation, if you see Manning's coefficient, that's when you need to know that you need to use the Manning's formula. In this case, the friction factor tells you that you need to use the Darcy's Weisbach equation, or the Hazen-Williams coefficient tells that you need to use the Hazen-Williams. So the L is the length of the pipe here, and d is the diameter of the pipe, and v is the velocity. If the velocity is not given, something like a flow or discharge is given, and if the diameter is given, you'll be able to find area. So you'll be having this thing, and you need to find velocity. So sometimes they'll trick you with not giving the velocity directly, but giving the discharge or some other stuff in place of velocity. Just so you need to remember that you need to impose this formula and then put it the resultant value into this formula, and then you'll be getting the hydraulic, no, sorry, the friction loss in the pipe. And then we have the Hazen-Williams equation, the same terms again. The L gives the pipe length and D is the diameter of the pipe, where Q is the discharge. And sometimes they might ask you to calculate the velocity using the Hazen-Williams coefficient. If the Hazen-Williams coefficient comes in the question, you need to straight away go to the Hazen-Williams equation and find whatever it's needed. You can find the head loss or the friction loss or the velocity or the discharge using the Hazen-Williams formulas. All you need to do is put in the values that they give you, and you'll be able to answer or get the answer for this. The only trickiest term here is the hydraulic radius, or the S is slope here, which tells like a normal thing y over x. This is delta y over delta x, or the height difference in, let's say this is point P1 and this is point P2. This is at distance y1 from the datum and this is at y2. The slope here over length of L. The slope here is given as the vertical height drop, which is y1 minus y2, since y1 is higher, over the course of length L. This can be written as y over x in simple terms, as we learn in mathematics. So S is slope here. And the hydraulic radius. So you'll see the hydraulic radius in Manning's equation as well. So the hydraulic radius is nothing but the wetted area to the wetted perimeter. You need to know, like, let's say a circular section and the water is flowing right here. And then you need to know that in order to calculate the hydraulic radius, you need to calculate what this section of the area is, not the whole section, since this is the only section that is wetted. So the area wetted over, you need to find the perimeter that is wetted. And you don't need to consider all of this area. So the wetted perimeter. And this gives you the wetted area over wetted perimeter, which gives you the hydraulic radius, which you can put in these equations right here. And also you can use the hydraulic radius to calculate the flow using Manning's equation when we go to the open channel flow. So that's how you calculate the friction losses in the pipes. And then you have the head loss, a question on the flow using the Hayes and Williams coefficient. So the question itself says the Hayes and Williams coefficient. That's when you need to know you need to use the Hayes and Williams formulae. So once you go back, this is, and the question is asking us to find the flow in the pipe. So you have the flow formulae for the Hayes and Williams, which is Q is equals to K into C into area into RH into S. I don't remember what the superscripts are. RH to the power of 0.63 and S to the power of 0.53. So since the head loss of a 3,000 feet long, the length is given as 3,000 feet, and the diameter is given as 20 inches, which is 20 over 12, which gives 20 over 12 is 1.667 feet. Again, this is a unit conversion here, which you need to be so cautious about. And we have the Hayes and Williams coefficient, which is C is equals to 120. So I don't know what K is. So you need to go back and see what K is. K is 0.49 for the SI units, and it's 1.318 for USCS units. If the question is in metric, you need to use 0.849. But if the question is in feet or in the US system, then it is 1.318, which is feet in our case. So we need to use 1.318 into the Hayes and Williams coefficient, 120, into the area, which is pi, into the diameter is 1.67 square over 4 into, I'm writing here, into the hydraulic radius is again the wetted area, which is pi into 1.67 whole square by 4 by the perimeter, which is 2 pi into r is half of it, so 0.8 something, into whole power of 0.64 into the slope here is, they didn't mention anything about the slope directly, but indirectly they gave you the length of this. So you need to know that slope is, so you need to find Q, and then the slope is nothing but 15 feet over 3,000 feet, and to the power of 0.53. Since, yeah, the head loss in the pipe is given as 15 feet. So this, the pressure difference is given as a head loss, which is 15, which is measured as pressure difference in height. So 15 over your x is the total length, which is 3,000 feet. So 15 over 3,000 to the power of 0.43. You have everything you need to put in the formula, and that's when you get your Q to be something. So I'm not calculating all of these using my calculator, but going forward, we'll discuss the problems in detail. In order to save time and having the time constraint, I'm going fast pace and not solving too many problems here. But once we get it to a point where we can discuss everything in detail, we'll go through different problems and different types of problems that might be asked in the exam. So the points A and B are separated by 4,000 feet of a new 6-inch steel pipe. So you see all the other units are in feet. As soon as you look into the question, it's in gallons per minute, which you need to convert into feet cube per second to make all the units consistent. So it's 6-inch, so it's 0.5 feet. The first thing I do is focus on the units for hydraulics or water resources. Units play a key role. So it's a 6-inch steel pipe, so 0.5 feet, and a friction factor, so 0.0165. If a friction factor is given, you need to know that you need to use Darcy-Weisbach equation for calculating the head loss. They didn't ask us to find the head loss anywhere in this question, but a discharge is given and the pressure at some point is given, and you need to find the pressure at some other point. So for this, whenever you see the pressure at one point and you were asked to find the pressure at the other point, you need to use the energy equation or the Bernoulli's equation. The reason why we are using the energy equation here is because of the head loss term, which is not considered in the Bernoulli's equation. So the energy equation goes something like this: V1 square over 2G plus Z1 is equals to P2 square over gamma 2 plus V2 square over 2G plus Z2. So let's say the PA here, PA and A, since A and B are given, we'll do B here and then B. So the pressure at A, which we need to find, over gamma A plus the V squared by 2G. They didn't mention anything about the velocity here. So assuming the velocity is same at both the equations, so it gets cancelled out. And then I'll send this ZA into the other side, which will be ZA. So the reason why I did is it says the elevation difference is 55 feet. So this ZB minus ZA will be 55 feet. So this will be my PB over gamma B. PB is given as 50 psi. Since all of my units are in feet and this is in inches, so the 50 pascals for inch square is converted into 144 inches square per 1 feet square. So 1 feet is 12 inches. So once you're squaring the feet, it will be 144. Always write the equation or the conversion something like this, just so you don't miss something, that you can just see, like if I'm canceling the inch square, what I'm getting here is 50 pascals into 144 divided by 1. You'll be getting something in the feet square. So you'll always won't be making any mistake once you write your unit conversion something like this. Let's say if you have 1000 gallons per minute into, let's say you need to convert it to gallons per seconds, in this case not feet cube per second. So you need to write it something like, you have, so you need all of these, the denominator and the numerator needs to be cancelled out. So whatever it's in the denominator, it goes into the numerator here. So the 1 minute, it contains 60 seconds. So that's when you know you're having the unit in gallons per seconds. This way you don't make mistakes in the unit conversion. So once you just write it, then I think there might be a higher chance of doing a mistake. But whenever you write your unit conversions, something as a numerator and denominator, and then cancel it out and see if you're getting what is needed, that's when you're good with your unit conversion. Let's say you have gallons per day here, and then you need to see 1 day over 24 hours, and then you need the targeted unit to be gallons per second. So in 1 day you'll be having 24 hours, and in 1 hour you'll be having 3,600 seconds. So this hour and then the 24 hours here gets canceled, and then 1 day here and then per day here gets canceled. And the end of the day you'll be getting gallons per second, which is what we needed. So whenever you do a unit conversion, try to write it in this manner, just so you don't forget some unit conversion in the sequence. So coming to our question here, the pressure at the point B is given as 50 psi, and once you convert it, it is 50 into 144 over the gamma at B, which is water in both the cases. So it says water, so the gamma B is water, plus ZB minus ZA is 55 feet, and then we need to consider the HF, which is head loss with the friction factor. So whenever the friction factor is given, you need to think about the Darcy-Weisbach equation, which is F into L over D, which is L over D into V squared over 2G. And you have the friction factor, you have the length, which is 4,000 feet, and then you have the diameter to be 0.5 feet, and then you don't have the velocity given here. So that's when you need to think of Q is equals to A into V, which is an important formula again. So they gave you the discharge in 1000 gallons per minute, which you need to convert into feet cube per second. I think the gallon to the feet cube is given in the handbook on the first page of unit conversions. It is somewhere 0.18 or not. I don't remember. I don't want to go back and waste the time here. And you need to convert the minutes into seconds. That's when you have the Q in feet cube per second, which is in the same units that we need. So once you put in, and you need to find the the velocity here. You have the diameter and you have the q, which is pi d squared by 4, and the only unknown here is v. Once you know this v, you need to put this in the hydraulic, sorry, the friction loss in the pipe, and put this value right here. You will be getting the pressure at the other point, which is pa. So that's how you calculate. I know this is kind of messy, but I'll habituate to do it in a nicer way. And I don't have the solutions in the PPT anywhere, so it's tough to explain. But going forward, I'll make sure to have my solutions in the PPT just so you all can see the solutions clear step by step. So the pipe network series. So this picture is in the handbook. I don't know where it's located, but it's in the handbook. And the pipe network analysis tells whenever the pipes are connected in series, the flow rate is same. The Q1 and Q2 and Q3 is same. Q1 is equals to Q2 is equals to Q3. And the head loss adds up. The total head loss is equals to HF1 plus HF2 plus HF3. If the friction factor is given, we need to use the Darcy-Weisbach equation and find the friction factor in all of the cases, and then sum it up to get the effective or the total head loss in a pipe connection that is connected in series. And if you have the pipes in parallel, then the total head flow is equal. So whatever that's coming in, the Q is going out, but it's distributed into two other pipe systems, meaning the total Q is split into QA plus QB, and end of the day, it's coming to be the same. So the total flow is splitting into two pipe networks here, which means the sum of the flow rates is considered in the pipes in parallel. For pipes in parallel, the head loss is same as in vice versa. HF1 is equals to HF2 is equals to HF. So the head loss remains same in the parallel connection, but whereas it's opposite in the series connection. So if you remember one of these, and it's easy to remember the other. So always remember the Q, whatever the Q that's coming in, the Q is coming out, but it's split into two pipe networks. So the Q gets added up, and finally it comes to be the same. So Q is equals to QA plus QB. But the hydraulic or the head loss is equal in the parallel connection, is the total head loss. And it's vice versa in the series connection. So if you remember one, it's easy to understand or to remember the other ones. And going to the hydraulic conductivity or the permeability of the fluids here. So to measure the fluid permeability or hydraulic conductivity through, let's consider soil, let's understand this in an easier manner. And you have the water somewhere here, and for the constant head and for the falling head. For the constant head, the naming itself says the head remains constant, meaning we try to keep the head of the flow constant all the time until the experiment is done. So this could be with a tap water or something that's flowing continuously, and if you have a protrusion here, the water will be flowing out. So all the time we try to maintain the head to be constant whenever you're performing the constant head test. And as the name itself suggests, the falling head, over time we only provide just once, the water provides just once, and over time the water gets sinked into the soil right here, and the hydraulic head gets decreased over time. Let's say it is 10 centimeters for the first 5 minutes, and then for the next 5 minutes, it might be 8 centimeters. So, meaning the hydraulic head is getting varied here. So, since it is called as falling head test, so you have formulas for both of these, and then it tells what the terms is. Q is total quantity of water or the flow, and then A is the area, and then I is nothing but the difference in the hydraulic head over the length, which is in feet per feet or meter per meter, and then A is nothing but the area. And in the same way, you have the hydraulic conductivity or permeability formulae for the falling head test, which is all of this long equation right here. You'll be given all of these in the question. You just need to plug in and find the answer. But the only trickiest thing, or the one of the key point that I just made based on the mock test that I wrote, or the questions I've seen in the full length test, is in the question they try to trick you asking the hydraulic conductivity test is conducted on a coarse grained soil or on a fine grained soil. You don't know what formula to use. Sometimes you'll be able to understand if only one height is given, you need to find the constant head. But sometimes you'll be able to understand with the two heights given, you need to use falling head. But if that's something as a theory question, you need to remember for coarse grained soils, we use constant head method. And for the fine grained soils, we use the falling head test. So the reason how I remember this, even completing my exam long back, is these are some silly things, but this helps you keep, memorable all the time. The coarse grain soils, since it starts with C, and I just remembered the constant head C. So if you have C and C, and you need to remember F and F, meaning the constant head test for coarse grain soils, and the falling head test for fine grained soils. So that's how you remember. And if you remember in this way, you'll be able to remember for a long term that it's a simple understanding and keeping an extra effort of finding something that you can relate so that you can remember further. So that's how the hydraulic conductivity is measured or calculated. And then the Darcy's law, or coming to the Darcy's equation, it tells that the flow is directly proportional to area into dH over dx. And once you remove this proportionality, you'll be getting a factor which is hydraulic conductivity over dH over dx. It's a direct formula. You just need to plug in the values. Sometimes they give the hydraulic conductivity in feet cube per day, and depending on the units or the solution, you need to convert this to feet cube per second, which is 1 day has 24 hours. It kills your time, but it always helps you keep track of the unit conversion. That it makes sure you don't miss anything. It's there's a high chances of missing the unit conversions. Sometimes you just convert it to minutes and the answer tells it needs to be in seconds. So that's how you make some mistakes. So it takes some time to write in this way, but helps you keep track of the unit conversion that you're doing. So that's the Darcy's law. And then you have the unit hydrograph. We cover more about the unit hydrograph once we move into the hydrology part. But to understand, the unit hydrograph is a direct runoff, meaning it doesn't take account of the base flow. It tells the direct runoff is not taking consideration into the base flow, which is already in the soil. So the total direct runoff that's happening for 1 inch of rainfall, which is the unit of rainfall, 1 unit of rainfall is called the unit hydrograph, or 1 centimeter of rainfall in 1 inch of rainfall. That's the unit hydrograph. And then we'll discuss more about the unit hydrograph and the problems in the hydrology, which focuses more on the hydrographs. And the transmissivity formula, it's something to be hydraulic conductivity multiplied by the thickness. So it's sometimes whenever you need to use the hydraulic conductivity, let's say in this case, they might give you and trick you, they give you the transmissivity, and the width of this is maybe 20 feet or something. That's when you can convert the transmissivity into the hydraulic conductivity and then put it in the formula that is required. They might trick you sometimes by not giving you the exact value, like the velocity with q is equals to av. Sometimes they only give you the diameter and the flow, and you need to know what the velocity is and then put it in the right spot wherever it's needed. And then going to the aquifers. So the aquifers is a natural, underground layer of permeable rock or sand or gravel that holds and transmits the water. Meaning, we have both the aquifers here. Imagine of a well that's drilled into the soil, and there is some soil layer right here, and there is some rock layers. There might be different strata of soil or rock layers underneath the actual ground surface. Actual ground surface. So the unconfined is open to the surface, meaning it gets recharged with the effective rainfall whenever a runoff occurs uh, above it. This is causing or it makes it recharge. The unconfined is open to the surface and the water table is top and it gets recharged with the direct rainfall that's occurring with the runoff. And this layer right here is considered to be confined aquifer. The reason behind it is said to be confined aquifer is it's trapped between the two impermeable layers, or it is confined between the two layers at the top. So that's the reason why we call it to be the confined aquifer. And we have good descriptions in our handbook, like what's the different formulas that you need to use in order to calculate the total flow rate that's being drawn from this well for an unconfined aquifer and for a confined aquifer. So based on the radiuses, the radii and the height, you need to know which formula to use, whether it's be unconfined or confined, and you need to put in the right formula and put in the biggest thing in this type of questions and where people often make mistakes is knowing the height or the radiuses from the given question. They don't give you the height h1 is 20 feet or the height h2 is 40 feet. They'll give something in a verbal language saying the height of the water level from the bottom of the aquifer is 20 feet. That's when you need to understand the h1 is 20 feet. And based on the given terms or entities in the question, you need to know whether to use the Dupit's formula or the theme equation for the confined. Sometimes they just mention in the question that it is an unconfined aquifer or a confined aquifer. And based on that, you can use the equations. I don't know if we are running out of time. I'm continuously just speaking because of the time constraint here, but Manidhar, do you have any time constraint? I think I still have maybe 6 or 7 slides, but it takes some time to go through it. Is that fine, or you want me to stop here at this point?
I don't have any objection, but let's hear out from our participants if they're having any.
I think we only have maybe 5 to 6 slides. I'll try to
So,
complete that as fast as possible.
all right, so then we can take over it. I
Okay.
mean to say, let's complete it. Why to
S-
stop
s-
in between?
Yep. Okay. So based on the question, you'll be knowing whether to use the unconfined or confined aquifer and then put it in the equation, and then you'll be able to solve what the flow rate of the water drawn from the well. Sometimes they'll give you the Q and they'll ask you to find H1 or H2. You need to rearrange this equation in order to find whatever that's asked in the question. So that's the same with the confined aquifer. You need to know the formulas here. And we have a question here. Let's go to the question real fast and just write what are the terms given and see what formulae is suitable for this question. And yeah, we don't spend time in solving this, but we'll put everything that's given. So the unconfined aquifer, it's given in the question, so you don't need to worry about it. So you need to know that you need to use Tippett's formula since it's unconfined. So the formula goes Q is equals to pi k into h2 square minus h1 square over ln r2 over r1. Since the original water table is 200 feet from its bottom, saying is that h1 over h2, h2 over h1. Okay, so we have h1 to be 200 feet and to access a water well with a radius of 1 feet. Since the radius is given, the radius of the well is r1 here, so which is 1 feet in our case, and the pumping rate is given as 80 gallons per minute, which you need to convert into feet cube per second since we have all our units to be in feet. So see what the gallons to feet cube conversion is, and based on that, you can convert the minutes to seconds as well. The 1 minute has 60 seconds, and then you'll get something in feet cube per second. So you'll get the total Q in feet cube per second. So you have Q in feet cube per second once you solve this. And the hydraulic conductivity, which is K, is given as 1 feet per day. Since you have your total flow in feet cube per second, you can convert the hydraulic conductivity into the feet cube per second, similar to the other units here. So 1 day has 24 hours, and then 1 hour has 3,600 seconds. So this hour gets canceled, and the days gets canceled. So end of this equation, you'll be having the feet cube per second, which is similar to all our other units to make it consistent and use in this formula. And the well drawdown is 0 at a distance of 1,500 feet. So the distance R2 is given as 1,500 feet. And after pumping is continued long enough to reach the steady state conditions, what will be the approximate depth of the water in the well? So basically it's asking us, so all of the other things are given except the H2. So after rearranging this equation, you can calculate what H2 is since you have everything that's needed. You have R2, you have R1, you have H1 to be 200 feet, and you have K, which is something into feet over second, which is the same units as feet cube per second as the flow. So by putting all the things in here and solving for H2, that's give you the answer here. Let's go into the open channel flow. So the open channel flow is simply when water flows in a channel with its surface open to the atmosphere or the air. Think of rivers or canals or drainage ditches or even water flowing in a gutter. Now there are a few ways we can understand or we can classify this open channel flow into different types here. We classify them as steady or unsteady or uniform, non-uniform, subcritical or supercritical. The steady flow means the conditions stay the same over the time. The depth of the water and how much is flowing past a point doesn't change. Imagine a river flowing on a calm day, flowing at the same depth all afternoon. That's considered to be steady flow. Unsteady flow means either depth or discharge changes with time. So, like during a flash flood warnings, the water levels are rising or falling, meaning the depth of the discharge change is changing with respect to the time. So that is classified as unsteady flow. And once you go to the uniform or the non-uniform flow, The uniform flow means the depth and the velocity stay constant along the length of the channel. For example, in a long straight irrigation channel with no, let's consider it to be a trapezoidal channel with the water flowing, no slope changes, meaning the depth and the velocity is constant along the length. And for non-uniform, it varies. It's just vice versa. Once you remember one, it's easy to remember the other. And the subcritical or the supercritical flow is divided or categorized based on the fluid numbers. So based on the fluid number formula is given in the handbook. It is v is velocity over square root of g is acceleration due to gravity, and y is the depth of the flow. So the y is given as area into t. T is nothing but the top width. Let's say a trapezoid section of the channel where the water is flowing. You have the bottom width to be 4 feet and you have the top width to be 6 feet. Okay, sometimes they'll trick you by just giving the bottom width and they give you some slope like 1 is to 2, or if your y is 1 and this is 2, and you just need to know or calculate what this is based on the given slope, like divide this into sections, and this is exactly similar to 4 feet. And based on the slope, if you get to know that this is 2 feet and this is 2 feet, then the top width is 4 plus 2 plus 2. We'll do much more problems on all of these, like the Manning's equation or the open channel flow. In that case, you'll be much clearer how to find the top width and the bottom width with the slopes. So in this case, it will be 8 feet. So the T here is representing the top width. It's not just the width. Something to keep in mind. So once you get the Froude number calculated, if the Froude number comes out to be less than 1, then it's subcritical. And if the Froude number comes out to be greater than 1, then it's supercritical. Or in the subcritical, it's slow and deep, and in the supercritical, it's shallow and fast. And we'll discuss about the supercritical and subcritical, one more way of classifying it with the specific energy. So, talking about the specific energy, assuming that the shape of the channel as so, let's consider it in a graphical representation. It says the energy, and then the depth is in y. So considering the channel as well as the flow rate conveyed in the channel both remain constant, increasing the flow depth also increases the potential energy 1 to 1 at a rate of 1 to 1. So the potential energy is y here. So alternatively, as we bring the depth up, since the area enlarges, and let's consider the q is constant in this case, meaning we see a decrease in the velocity since the area is larger and the q is constant. Q is equals to a into v. Since the area is more and this is constant, to balance it, it needs to be less. So the velocity gets decreased. But the velocity head is defined with a v squared term. In this case, is v squared over 2g. Okay, so this is how the kinetic energy is represented over a flow of a channel on the bed slope. So the summation of the potential energy and the kinetic energy in an open channel gives what is called the specific energy as represented in the handbook. So this is the graphical representation behind understanding how this equation came out. So if the depth of the flow is greater than, so yeah, one more thing to understand here, the depth at which we have the minimum specific energy is called the critical depth. If the depth of the flow is greater than the critical depth, then it is called as subcritical. And if the depth of water or the flow comes out to be less than the critical depth, it is called as supercritical. Something to keep in mind for theory questions. You'll see good amount of theory questions on your exam as well, from geotech and hydrology and structures even. So something to keep in mind. And you have the critical depth formula. These are direct equations. We'll discuss more how these came and how what are the practical applications of these formulas going forward. But for the rectangular channels, it's directly given to calculate the hydraulic depth. Q is the discharge per the width squared into whole to the power of 1 over 3. That's how you get the critical depth for a rectangular channel. And then going to the hydraulic jump. What actually causes the hydraulic jump? Let's say the depth of the flow. Let's consider some flow. This is considered to be hydraulic depth. As you see, when a tap is turned on in a sink, you see the ripple formation or the shape something like this, which is called as a hydraulic jump. Let's consider the depth at the left side of the section to be y1, and the depth of the flow on the higher side is to be y2, which is subcritical and supercritical. So the y1 and y2 depths is nothing but, if you see something as in specific energy formula, you will see the depth somewhere here and another depth here. So the y1 and y2 are called as the sequent depths since we have the same specific energy. Since the supercritical velocity is always greater than the subcritical velocity, to compensate the energy or keep the energy constant, the energy of the water literally jumps. Now, this hydraulic jump depends upon a parameter known as a Froude number. So the hydraulic depth or the depth of the subcritical flow or the supercritical flow is calculated using the Froude number. And the Froude number formula is discussed before. So another parameter that helps us to understand whether the flow is supercritical or subcritical based on the Froude number. So if the Froude number increases, the jump becomes more and more pronounced. The hydraulic jump that you find in your water sink, as in this case, has lesser Froude number, whereas the hydraulic jump defined in stream, like a river, fast-flowing river, has a higher Froude number. So it is more pronounced if it has the higher Froude number, and if it is less, it will be like at a lesser pace. So that's about the hydraulic jump. And discussing about the Manning's equation, I think this is the last topic we have. We can discuss about this faster. So the to calculate the flow rate of a flow in a channel or in any section, in the circular section or rectangular or in the trapezoidal section, we use something called as a Manning's equation in order to calculate the flow rate in an open channel flow. Let's consider a trapezoidal section where you have some flow flowing on. So in order to find the Q, which is a flow rate, or the velocity, you see a good amount of questions from the Manning's equation for both FE and PE. And this is the basic stuff that everyone should know. So the hydraulic radius, as I told you, is the wetted area to the wetted perimeter. So depending on the circular section, if the flow is at this point, you have a graphical representation what to use. Like you have d over d term. I'll tell you where that is in the handbook and how to find the hydraulic radius. And for some cases, I think there is a tabulation in the handbook which tells the hydraulic radius for different sections. So based on that, you will get RH, and you have the area, and then K is a constant, which is given as 1.486 for US CS units and 1 for SI units. And S is the slope, which is Y over X, meaning the head difference, or H2 minus H1 over the length X, or over the length L. Let's say the height is H1 over H2. So H1 minus H2 over length gives you the slope of this particular flow. And once you put in all of these into these equations, you will be able to find the total flow rate or the discharge or the velocity. The only thing you need to remember is the units again. Sometimes they might trick you giving the diameter in centimeters, and you have the velocity in meters per second. That's when you need to convert all of these into meters and then put in the equation. That way you'll know the solution, exactly what it's needed. Going to the last question, a circular metal storm pipe under a road is deformed due to excessive vehicle loads as shown in the figure. So basically, due to the load, the circular pipe is deformed into ellipse. So what happens to the capacity of the pipe here? So will that increase or decrease or remains constant or it stays same? So the Q based of the formula that we just discussed, A is equals to Kn into RH to the power 2 by 3 into S to the power of half or something. So since RH tells area over perimeter, but since the perimeter is staying the same, right? The total perimeter of a circle is just transforming into an ellipse. So the perimeter stays the same, but the area here decreased, which makes RH to be lesser, meaning the capacity decreases. So whenever there is a deformation of a circular section pipe into an ellipse, the pipe's capacity decreases. It looks like a theory question, but the hidden soul of this is in the equation that we just discussed, like how these are related. The area is related to the pipe capacity. So you need to know this in order to answer this question. So that's the end of this presentation. I think I've taken more time than needed, and I went fast because of this time constraint. But going forward in future, we might be able to solve all of these, going in detail, solving maybe 2 or 3 types of questions just for hydraulic jump or specific energy, or in Manning's equation, we'll be able to solve maybe 3 or 4 sections, the trapezoid section, the circular section, for the rectangular section, just to make you all familiarized with all of the types of the questions that will be asked. So I have a good amount of questions that I can frame, and also some key points in all of the topics that you need to remember, which are not covered in the handbook, which I will share with you going forward, taking consent from the people here. But I think that's the end of the session here. If anybody have any questions, and sorry for taking all of your time so long. It's supposed to be just 1 hour, but it went to be 2 hours. Sorry for that. But yeah, we'll make sure to be within the time range going forward. This is a whole topic, and it's tough to cover it in one class. So yeah, but somehow we managed to at least cover briefly what are the topics included in the FE point of view. So if you have any questions regarding the FE exam or something technical, you can go ahead. The session is open, or we'll end this for now if nobody has any questions.
If nobody got any questions, then I'd like to say something here. Even if it's an extraordinary session, you completely like starting from the session, the way you started your story about your FE journey, it is completely fascinating, and it it definitely motivates if any new person, or if a person who doesn't have any knowledge related to FE, if they listen to your story and the hurdles that you have been through. So definitely it's an inspiring story and like an interesting story to each and everyone. And not only that, you had a great journey. When I can say, I mean to say that we everyone starts with zero, right? And in your case, what happened is you started your FE almost at your third semester, and in between fourth semester you got it, and from there you started climbing your ladder. And similarly, so we may not, this is for everyone, we may not recognize the importance of your fear at the minute itself, or during the point of preparation, during the time of
Yep.
preparation, but eventually when you complete it and when you progress in days of your life, then you will come to understand the importance of what you had done. The way you are seeing Mr. Vineeth here today, he cleared his PE in construction, and soon he will get his license. Once if he gets his license in his hand, as he stated earlier, like if you're having your license with you, then you got that right to open your own consultancy on your own. But if you do not have that particular license, then it will be a hard task for you to get the proposals done. Just just because of this PE license, people gonna hire you so that they can submit proposals on your name, which will be a value added thing to you and to the license that you achieve. And most importantly, the webinar is meant for water resources engineering and the key concepts which are assigned and aligned with them. So the way you took the topics from A to Z, and also the importance of unit conversation that you explained here is outstanding. And like it gonna get injected to each and every participant's mind, that I can feel it and I can say it. And if any one of you got anything to Mr. Vineeth, you can shoot a question to me or to him. If it is something general thing, then I'll answer. If something it is technical, then Vineeth gonna take care of your questions.
Sorry to interrupt here, Manidhar, but yeah, that's great. You're talking about me, but yeah, I know I went so fast paced on all of these topics since we need to cover the whole bunch of water resources topic in given 1 hour, 2 hours time frame. So, and the first session went so long that I didn't even expect that people have got with some good questions. So we were answering those and it delayed our time. But yeah, it's difficult, and I went fast paced on some of the problems. I didn't even solve the complete solution, but going forward, we'll make sure to solve each and every question in detail since we get enough time to complete each and every topic. I'm sure I'll be able to teach you the best I can since I gave my PA recently. I know what will be asked and how the examiner might be thinking or where the students will be tricked or making mistakes. So, yeah, with that, I think I'll conclude myself. If anybody have any questions, thanks for listening so patiently, so long. It's been 2 hours, so I really appreciate it. But yeah, thank you so much, and it's a wonderful opportunity for me as well to showcase the knowledge that I have and share with you all today. Thanks, Manidhar.
Thank you. You are welcome, Vineeth, and thanks should be from our end. Pleasure is ours to meet a person like you and to get some useful and informative tips from you, definitely. And one more minute before terminating the session, here we would like to announce you about our upcoming batch, which is batch 6. We're gonna start it pretty soon. If I'm not sure, Venki, are you available? If so, can you drop the poster? I think no, but still, yeah. You can inform your friends, or if you'd like to join us for the batch 6, then definitely you are welcome. We're gonna start the batch 6 as soon as possible. We'll release the date, starting date for
Sure.
batch 6 too. All
Sure,
right.
for sure. And I'll share with the network I have and with the people who are studying. I always encourage people to give the FE exam during their studies or whenever they're doing their masters. It helps them to secure a job. We'll discuss it all about this going forward. It's gonna take some time, but yeah, for sure. I'll let everybody know in my network or connections about the new batch that you guys are starting.
Yeah. And finally, let's end up this session with a small end note saying there was a question by one of the participants saying that he got lost while he was attending the sessions because of whatsoever reason. So for that particular person or persons whomsoever encounter with this kind of difficulty during the preparation process, just try to understand what motivated you to take up the course and what motivated you to start your direction towards FE. So the same fuel you need it to motivate yourself daily. It is not simply the initial motivation that you may get to start the FE, but the thing is, you need consistency in order to keep your goals and fire inside you, keep it like alive. When you have that urge to get the things done, then only we will be able to get these things done. Like, and FE is not a like short term thing, it is like a long term consistent thing. So definitely consistency gonna play a crucial role here. And once again, try to pull the motivation into your mind, which initially fueled why FE is essential for you. So that kind of perspective definitely gonna give you some positive thing and positive mood of preparation. And on top of everything, above and beyond, try to schedule your exam, so that scheduling your exam definitely gonna kick you some positive pressure, which is much crucial for you. And kicking the clock gonna benefit you in such a way that you have to prepare subjects at the faster pace than you do. All right. So that's one tip. And with this, we're gonna sign off.
Thank you. Thanks, everyone.